Hey everybody, in today's tutorial we will be discussing circles and area, and more specifically circles and circumference. Today's learning target is I can describe a circle in terms of radius and diameter. So let's look at a little bit of the history behind this. This guy over here is Archimedes, and he was a Greek mathematician, a physicist, an engineer, and an astronomer. You can say he was a pretty smart dude. And he discovered what maybe you've heard of before, this number that we call pi, pi, different than an apple pie. But he discovered that in any circle, the ratio of circumference to diameter is always the same. Your circumference of a circle is the distance around it, and the diameter is the distance across the circle. And that ratio between circumference and diameter is always the same. And he gave that a number. He called it pi, or the symbol for pi, which comes from a letter from the Greek alphabet. So that's a little bit of the history behind it. Let's look at a little bit of the vocabulary. The first term is a circle, and that might seem pretty obvious, but a circle is the set of all points in a plane. So if you could put a point on each one of these dots, they're the same distance from the center point called we're going to be very technical here, the center. So if I were to put a point here, that's this distance from the center is the same as that point, as that point, as that point, as that point, right? It's the center. The blank, in the box here goes radius is, let me get back to the pen here, the distance from the center to any point on the circle. And that's that red line here. And in green, the diameter is the distance across the circle through the center. All right, so you might see that there's a little bit of a relationship here between our radius and diameter, and that's what our key idea talks about. Okay, the diameter of a circle is twice the radius, and it kind of looks like that. The diameter is 2 times as big as the radius. So that would mean that the radius is half of the diameter. Let's just put that into a real easy algebraic equation. The diameter would be diameter equals 2 times the radius. It's the radius times 2. Or you could think about that relationship as the radius is the diameter divided by 2. Okay, so these two equations should be pretty helpful for you. I would definitely write those down. All right, so let's look at one of the examples that you might see. It says the diameter of a circle is 20 feet. Find the radius. Okay, so we're looking for radius. I'm going to use that formula. The radius is the diameter divided by 2. Okay, well, in this case, our diameter is 20, the distance across the circle, divided by 2. My radius would be 10, and my label would be feet. So from here to here would be 10 feet, half of the diameter. Okay. And then the second one, letter B, the radius of a circle is 7 meters. To find the diameter, well, to find the diameter, I take 2 times my radius. So 2 times 7 would give me 14, and my label would be meters. So twice this. All right, go ahead and pause the video now to try 1 and 2. Alrighty, for 1 it says the diameter of a circle is 16 centimeters. Find the radius. Okay, so you'd cut that in half, so it would be 8 centimeters. And then the radius is 9 yards. Find the diameter, so multiply it by 2. You should come up with 18 yards for that diameter. Okay. Pretty basic. Let's now add in another term that we had talked about at the beginning. The distance around the circle is called the circumference. Kind of tricky to spell, circumference. That's the distance around. Again, the circumference, the ratio of the circumference over the diameter. If you take circumference and divide it by diameter, that's the same for every circle. And that's that letter called pi. P-I. It's from that Greek letter. Right? The value can be approximated as 3.14. So pi is this symbol, and it's 3.14. It keeps going, but we can just approximate it to that. Or we can call it 22/7 as well. And if you were to take 22 and divide it by 7, you'd come up with 3.14, blah, 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 and it'd keep going, right? The reason we sometimes use a fraction is because our math will sometimes be given to us in a fraction. So rather than convert all the time, we'll just keep it as a fraction. Okay, so let's see our key idea and see if we can figure out, to be a little bit more exact, some algebra. The circumference C of a circle is equal to pi times the diameter, or pi times twice the radius. So that might sound confusing, but let's just write it out. Circumference is equal to pi times our diameter, or you can think about it as 2 pi times r, because 2 times the radius just is the diameter. All right, so one equation is using diameter, one equation is using radius. They're the same thing. Okay, you can use either one of those to find circumference. All right, so here we got a frisbee. It says, find the circumference of the flying disc. Use 3.14 for pi. All right, well, I'm given the radius here, so I'm going to use the formula that has the radius. So circumference equals 2 times pi, and I'm going to use 3.14 times radius. All right, so that equals 2 times 3.14 times my radius, in this case, is 5 inches. Okay, so you can plug this in the calculator if you want. 2 times 3.14 times 5 should give you 31.4, and that would be in inches. Okay. Again, that's the circumference. That's this distance around the frisbee. All right, let's try another one here, and we're going to use the watch face, so the face of the watch here. And in this example, we're going to use 22/7 for pi. If you look closely at the picture, it says that the distance across, so the diameter, is 28 millimeters. Okay, so I'm going to use my diameter formula here. So the circumference is equal to pi, and this time I'm using 22/7 times my diameter, and my diameter is 28 millimeters. And since I'm multiplying by a fraction, I'm going to make this whole number into a fraction by just putting 1 as the denominator. Right? And before I multiply, I'm going to make life a little bit simpler on myself, and I'm going to simplify. Divide each of these by 7. 7 divided by 7 is 1. 28 divided by 7 would give me 4. And then I can just multiply across. So 22 times 4 would give me 88 over 1 times 1 is 1. That would give me 88 millimeters for my circumference of this watch face. And again, the reason we use 22/7 this time instead of 3.14 is because we were dealing with a number 28, that was easily simplified right away, and it gave us a nice whole number. Okay. So I'll go ahead and pause the video here and find the circumference of the coin, the pool, and the plate here. All right. Hopefully you came up with 12.56 centimeters for the coin. For the pool, about 44 feet for the circumference. And then for the plate, about 28.26 inches. All right. If you had questions on any of those, be sure to ask me or phone a friend or figure out what you did do right there. Moving on, we now are going to work on estimating a diameter. So it tells us that the circumference of a roll of caution tape decreases 10.5 inches after a construction worker uses some of the tape. Which is the best estimate of the diameter of the roll after the decrease? Okay, so after the decrease, the circumference of the roll would be what? Let's first figure out that, because it tells us that initially the circumference is 31.4, but then a construction worker uses 10.5 inches. So how much do we have left? Well, we just have to take 31.4 and subtract 10.5. I might have to borrow. Okay, bring our decimal straight down. We get, let's see, 20.9. Okay, so now the construction worker, since they use that much, our new circumference is 20.9 after they use some. Okay. Now the question asks, which is the best estimate of diameter? So we know our circumference, and we need to find our diameter. Okay. So let's use our formula. Our circumference formula was C equals pi times our diameter. Okay, I know, let's plug in what I know. I know my circumference is about 20.9. Okay, so I got 20.9 equals pi. Let's just write in 3.14 times my diameter. And I don't know my diameter. That's what I'm trying to find. So now I have a simple equation. 3.14 times d equals 20.9. To undo multiplying by 3.14, I divide by 3.14 on both sides. That cancels to get me d equals, if I were to take 20.9 and divide by 3.14, I would get 6.7. Okay, and this asks for an estimate. So 6.7 we would round up to be 7 inches would be the best diameter after that construction worker took off some of that caution tape. Okay. Go ahead and try the on your own here. Please pause the video now. It says the circumference decreases 5.25. So you'd take that starting and you'd subtract 5.25. And then you just go about solving it the same way we just did. So you should come up with about 9 inches there. So let me know if you have a question on that one. Lastly, we'll end with finding a perimeter of a semicircle. Okay. So for example 4, it says a semicircle is half of a circle. And that looks like that, right? If you were to extend out this circle, this looks like about half. And it wants us to find the perimeter of the semicircular region. So that would be this. I'll try to highlight it here. This would be the semicircular region here. right? It says the straight side is 6 meters long. The distance around the curved part is half the circumference of a circle with a diameter of 6 meters. So if we were to pretend like we were finding the circumference of the entire circle, and since this is just half of that, we would essentially find the circumference and then divide by 2 to find this region right here. Okay, so let's use our circumference formula. Circumference equals pi times diameter. All right, pi times my diameter is, the distance across this circle is 6 meters. Okay, so if I were to take 3.14 and multiply that by 6, the circumference would be 18.84, and that would be meters. Again, that would be the circumference of the entire circle, but we just want to know what it is for the semicircle. So last step then is we would divide that by 2 to find out what half of that is. Should give me 9 point something, 9.42, and that would be meters for the semicircle. Okay. Now, that would be this region here. Is that semicircle region right here? Okay. If it wanted us to find the entire region, so if it wanted us to go from the perimeter around the whole thing, we'd have to take this semicircle region, which we just found is 9.42, and we'd have to add this bottom section of 6 meters to find the perimeter of the whole. So the perimeter of the entire shape would be 6 plus that 9.42 of just this region, and that would give us 15.42 meters. Okay, so just realize that you need to really pay attention to what the question is asking. Okay, in this case, I'd add that for the perimeter of the entire shape, I'd add that 6 meters. Okay, go ahead and pause here to do the same for numbers 7, 8, and 9. Okay, for number 7, I'll do this one together. You should come up with circumference equals pi times diameter. In this case, my diameter is 2 feet, so 3.14 times 2. The circumference would equal 6.28. Divide that by 2. We'd get, well, just the same 3.14 for this distance. Okay, the perimeter of the whole thing, then we'd have to add this 2 feet to give us 5.14 feet for the perimeter of this entire shape. All right, number 8, you should do almost identical to get about 18 centimeters. And the last one, kind of tricky, make sure this 15 inches, that's the radius, not the diameter. Diameter would be 30 inches. So the perimeter for the entire thing for number 9, you should get about 77.1 inches. All right, if you had questions on any of that, please let me know. And that wraps up this first section here on circles and area and circumference. We'll see you guys next time.